Hello, hello. Can you hear my voice? Hello. Can you see my this video? So before we get it started, I still uh, want to emphasize the price of this you I still want to emphasize the price. Hello. Hello, 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 hello. Can you hear my voice? Okay, okay. Uh, before we get started, I want to emphasize the price of this training. Okay, so we will award $100 to to those who passed the two N1 engineer. Okay, so two means the PLC and HMI inter intermediate certificate. Okay, one is the certificate of any other products like the Vbox or VFD or servo. Okay, and the last one is about the application project you have done. Okay, so this is 2N1. You will be get the bonus of this $100. Okay, so
Recording in progress.
so let's get in start today's topic. Okay. Can you see my PowerPoint, this presentation? Okay. So today's topic is about user-defined protocol. So we will divide into three parts of today's content. First is about the first is about what is the user-defined protocol, the definition. And the second one is about the configuration interface introduced. And then the third one is about practice. We practice this protocol on the Modbus. Okay. So first one, what is the user-defined protocol? So user-defined protocol is to hello. Hello. Hello, what about now? Okay. So user-defined protocol is main purpose is to communicate with the host device with non-standard protocol. Okay. So it is and this defined protocol is using the user interface to configure our protocol. So the next part is about how to configure about introduce about the setting. Okay, setting interface. So first we need to select the corresponding protocol before we doing the configuration. So both the Ethernet and the serial port available for this user defined. Okay, so you can see one is the user defined and one is the user defined TCP. So first if we want to enter this configuration interface, we need to click this button on the button left corner of this setting interface. And there is some option. Okay, so we can fill in or changing the setting. The first one it is this instruction edit is for set up the specific message format. Okay, of the HMI setting. And the second one is to set the HMI as the responser or requester. Okay, read or write. And the third one is to set the format, HMI message format. It is hexadecimal or ASCII code. No, number 5, this part is for filling the message content. Okay, or setting the received content. Check object is for filling the sending. Okay, and data list to learns tab is for filling the receive content. And the 6, this part is for add the instruction or edit, delete, or clean this list. And this advanced setting, it means to make one message to be a part of another message. Okay, so it is used when the message is dynamic part is more than one place. and this setting is only applied for the writing command. So if you trying to set it for the read message, you will pop up like the window like this. So because this message is not a target one, so cannot use this movement. Okay. So first it is the set the connection number. Hello. So is to set a connection number. It is referred to the connection setting. Okay. Communication setting. It must be the same from the same protocol. The second one is to set the byte range of the source message. Okay, it is transfer second. It is whether there is two parts to be moved, and the third one is to send the starting byte of the tagging message. And there is a relevant register for our user define. The first one is about the control bit. Control bit is 很卡。Hello。它就是 Hello. How about now? So sorry, the network is not stable. So there are some relevant register. Okay. So first is to menu sending. So this one control bit. So if the corresponding number of the bit, this bit address is triggered, then the HMI will send this message once. Okay. So for example, here I input the 12 here. So the one control bit 12. If I turn on it, you will send out this message. Okay. And another one is about the control register type. So control 0, it is about the communication enable and disable, and the control 1 is to for control the communication interval. So sometimes if the communication device like the microcontroller or MCU, it is not very fast. on communication, so we can set it slower by this register. Okay, and then the control 2 is for change check inversion XOR. Okay, and control 3 is for setting um, menu send control bit. So it is same purpose as this one control bit. And the last one is for set the allocation width. Okay, so if the value bigger, the communication speed is more faster. So it is like to set communication priority. You can regard it as this way. So here I using our the standard Modbus protocol as our example. Okay. So here we use the Modbus meter, voltage meter, as a read example, because we need to display the voltage value of 3 phases. Okay, so the corresponding address index is like this one. So it is 6, 8, 10. So this is 3 addresses. Okay. So according to the above table, the message format will be like the following this one. For example, here I read the A phase voltage. So the request is like this. Okay. Then the meter address and function code and the star address and register number and the CRC check. And here is for the response. So you can see here is four bytes. Okay. Because there's the menu indicates this data format is floating number. How I will describe later. Okay. So because it is a floating point number. Okay. So it will take up 4 bytes here. So the length is 4. So for example, here I set the fixed message same as this one. So you can see 55 03 and the following number. So you can see the exactly same to this part. And because we want to read the meter value. Okay. So I need to set the byte order. It is 32 bit. Okay. So set the number, and because I want to read the value, voltage value, so it is word object, and set the address is not conflict with other address. So it is any not config address is okay. So I set the data 6 here. And no, because we want to read the valid part. Valid part is only these 4 bytes, right? So you can see so its start byte is for 1, 2, 3, 4. So it is 4 byte, and the length is 4. So that's why we set that's why we set 4 here, okay. And because this response length is 9, so we set 9 on 9 byte on here. And at last we draw this mnemonic object data 6 on the screen, okay. So also we set the floating number for this data format. So here is for the easily observation, we use this Modbus slave to simulate the result, okay. So here I click connect, and confirmed the communication parameter, and changing the station number. Because hexadecimal 55 is corresponding to the decimal 85. So you can see it after communication successfully, the timeout is disappear. So you can see I set the increment for this number. A little bit faster for this GIF. So my station number is 85, okay, and I set the data format 32 bits. So you can see it is same value on this Modbus slave, okay. So this is for reading, okay. 55 it is hexadecimal number. because we need to change it to the decimal format, right? So it is corresponding to the 85. I can show you on the calculator. So you can see the hex is 55, and decimal it is 85. Okay. So that's why I input 85 on the Modbus slave. So this part is for reading. And also I demonstrate the writing. Okay. So here we use the VFD running command as right example. So because its address is 2000 sorry 2000 hexadecimal. So we, for example, I want to set forward running. Configuration we set reading hex the value how to read. On the configuration, we just need to set the length by the order. Okay, the actual actual data format still it is rely on this one. Okay. Rely on this one. 32-bit floating. On the configuration part, it only to require us to set its 8 bits, 60 bits, or 32 bits. Okay, it didn't require us to set this as unsigned or floating or not. So here is the writing command. Okay, so because it is write only. Okay, so it didn't require any response from the VFD. So here we set it as no receive. Okay, and here is the message format. And also we need to configure the data format and address. So here I set, for example, the bit object. Okay, which means if I trigger this data 2000, it will send out this write message. Okay, so here I demonstrate also same on the Modbus slave. So you can see if I trigger it, it will send two two messages together. So it is exactly same to our we configure on the interface. Okay, it's the 001 to 2000 address. But furthermore, here if we want to set the different value into this 2000 hexadecimal, okay, so we can set this write data field as blank because it is according to the user input. So here we need to fill in by this the check setting. So it is our Modbus is using CRC. So we tick this option and select check type as CRC. And the CRC range check range it is from byte 1 to the byte 6. Okay. So we need to set like this. Also, because those 2 bytes, because this 2 bytes, it is need to use user input, right? So here we change from the bit object into the word object. So dynamic part number will be changed according to this address, and we don't need to change this byte order. So the write data is from the so you can see it is from 1, 2, 3, 4, 5. Okay, this is 5. Start for 5 bit, and the 2 length is 2. So we add the extraction as position is 5 and length 2 here. Okay. So here, for example, we can configure the word switch or mnemonic into screen. Here I set it is the mnemonic object. Okay, and the write address is data 2000. So here we can see the value is sending to the Modbus slave. Okay. So here I input 1. You will send is 001. Okay. But as you can see, this byte order is not we wanted. Okay. So we need to this India order is not the same as our expect. So we need to change this byte order in the configuration setting. So after we change it into the big EDA, so you can see you appear on the you appear on the last byte before the CRC. Okay, so this format is what we want. Okay. Can you see this message a little bit small for this window? Y6. Which part? Which part you refer to? CRC, because if you check the Modbus menu, it will set the CRC check is for setting, is for checking the from byte 1 to the last value. Okay. So for this read command, it is for byte 1 to the 1, 2, 3, 4, 5, 6. So it is for byte 1 to byte 6. Okay. And for this response command, it is for 1, 2, 3, 4, 5, 6, 7. Okay. So it is to from 1 to 7. And so for this write command is same. So it is to from 1, 2, 3, 4, 5, 6. So it is from byte 1 to byte 6. Okay. So any other question for today's topic? How can we read ASCII data? So for ASCII it is just you need to just you need to change this format into ASCII code option. And also if we want to if you want to set a message, you can you can refer to the Google ASCII table. Okay, so for example, I want to set the if I want to change this one to the ASCII type, I can refer to this table to check which ASCII code is corresponding to this hexadecimal number. seems like it's not complete. So if I like this one, if I want to change into the ASCII a little EXT. Okay. So this command is not suitable for the example because it has some control command for this number. Maybe there is some. If you have some example on the ASCII directly, maybe will better to explain because I don't have on here, so maybe you have a question, we can talk after the meeting. Sometimes indeed there are some device is using the ASCII code to communicate. So we can we can like the to input we want it on here as long as we set is ASCII type. Okay. Okay. I will try to find one. So do you have any other question for today's meeting? If not, we are moving on the last step. Okay. The mini lucky draw. So today's lawful gift is our teacup. Okay. So please wait a moment.
那我还得搜一下，我得先关一下，然后搜一下。这个，中文吧，中文吧，大一点他们就看 看不见这些广告。
你声音红。
Hello everyone. Today's small gift is a teacup. Chinese people have the habit to drinking tea. I hope this small gift will bring your Chinese culture. 为什么回音啊？我靠，什么东西？输入手机没关。The first one is number 2. The second one is number 4. The third one is number 5. Congratulations. Okay, thank you everyone. 好了，结束。你还要继续吗？
Okay, okay. So see you on the next week. Okay. Goodbye, everyone.